All right, so here's 4.3, add and subtract rational expressions. Remember, when we add and subtract fractions, we must have common denominator. We must have common denominator to be able to add two fractions, okay? There's no way I can add 1/2 plus 3/5. There's no way I can add that unless I make them common denominator. I would have to multiply this side by a 5, which happens to be this other denominator. So I would have 5/10 plus, almost there. We need to be able to make this a common denominator. We will multiply top and bottom by a 2, and we would have 6/10. Now I can add these two fractions because they have common denominator. And that is the goal here. If I have a common denominator, I can add fractions. If I don't have a common denominator, I will make sure to make it happen, okay, by multiplying by another factor to make a common denominator. We like to call it the least common denominator, and that's what we're trying to produce here. It's something that is the least common between 2 and 5. It's 10. That would be our least common denominator between 2 and 5, okay? So I like to always tie into a number sense because our rational expressions rules is the same for simple fractions that we did in elementary school. So let's take a look at an example first. First thing I want to see is, do I have common denominator? I have a 3x squared minus an x minus a 2. And I have a 3x squared minus an x minus a 2. So they are the same. We are good. We can add this two rational expressions. As a matter of fact, the denominator stays the same. 3x squared minus an x minus a 2. Now I can go ahead and add the numerators. I have a 7x plus a 5 plus a 4x plus a 3. Okay, so all I'm doing is adding the numerators if I already have a common denominator. So 7x, we're going to combine like terms. 7x and 4x is 11x. And a 5 plus a 3 is an 8. All over 3x squared minus an x minus a 2. Okay? So there we go. If we have common denominators, we can go ahead and just add the numerators. And then there we go. We try to reduce and simplify if we can. We factor it, see if we can reduce it. I can tell you that this is not reducible, so I don't want to even waste time with this. We will not be able to divide. There's nothing common in the numerator here between 11 and 8. There's nothing in common that would be able to be reducible with something on the denominator. So we are done. Okay, we just added these two rational expressions into one fraction. Okay, let's take a look at another example. So here we go. Take a look at it. We have 3x minus 4 over x plus 3. Over here I have 2x plus 5 over x plus 3. We do have a common denominator. We're good to go. Okay? We can write this all over x plus 3 because we have a common denominator. And then we can just go ahead and add 3x minus a 4 plus a 2x plus 5. And then we just combine like terms. Okay? Now I was able to combine two fractions into one with the same denominator. We have a 3x and a 2x. That makes a 5x. And then I have a negative 4 and a positive 5. That makes a positive 1. Okay? So I take a look at it between 5 and 1. There's a binomial right here. There's nothing common for me to factor out. I am done. This is already as simple as it can be. Okay? So those are the easiest examples I can show you. And most likely we won't find very many of these, okay? We need to be good when the denominators are not the same. How do we work when things are not the same so I can make them be the same and make it easier? So what I would do is, here's an example where the denominators are not the same. So I have 2x minus 6 and I have a 6 minus 2x. They are completely the opposite. The 2x over here is positive. The 2x over here is actually a negative 2x. The 6 is negative 6, and here's a positive 6. If I multiply this side by a negative 1, either this fraction or this fraction, It doesn't matter which one. If I multiply one of them by a negative one, they would be the same, okay? So it really doesn't matter. Let's multiply this one. It really doesn't matter which one. But if I multiply this by a negative 1 all over a negative 1, okay, I'm doing a multiplication here. Here, I would still have a 3x all over a 2x minus 6. Plus, but now I have a negative 9 all over. If I multiply this, I would have a positive 2x times a negative 6. There we go. All right, I put it in parentheses. I like to see binomials in parentheses just to make sure it reminds me this is a group, okay, 2x minus 6. All right, so there we go. What's something that was completely different, I was able to make it the same by multiplying one of the fractions by a negative, okay? So now we can go ahead and add these two fractions because we have common denominator. 2x minus 6 is our common denominator. Now I have a 3x plus a negative 9. Now in this case, can I reduce it? Let's try it. We don't know for sure, but let's try it. If I reduce this, factor a 3 out, we end up with an x minus a 3, okay? Notice that 3x is divisible by 3, and we get an x. Negative 9 is divisible by 3, and we get a negative 3. Let's see here on the denominator. They're both divisible by 2's. If you take the 2, we get a x here, and negative 6 divided by 2 is negative 3. And there we go. Because we have factors, because we have 3 times a quantity and 2 times a quantity, and these two factors are exactly the same, x minus 3 over x minus 3, we can reduce it. Our final answer is 3/2. Okay? So take a look at this. It's amazing how our answer is just a 3/2 out of a fraction that was much, much more complicated. So there we go. That is how you do when the denominators are not the same. Let's take a look at another example to see. And this is, we already did this one, this is letter L in your worksheet, the letter L. So over here I have an x minus a 2. Over here I have x squared minus a 4. This is a binomial. As a matter of fact, any difference of squares should jump out at you right away. So here I have a 5 all over x minus a 2. Plus, I have a 3. I am going to factor this completely, and I'm going to get an x minus a 2 times an x plus a 2. So take a look at this. The denominators are not the same. These two quantities over here are the same, but it's missing an x plus 2. If I multiply this other fraction right here, this other rational, by an x plus 2 on the top and on the numerator and denominator, just like we did with the negative one, we multiply one of the fractions by a value that would make the denominators be the same. So there we go. Now I have common denominators. But on the numerator became something brand new. It became 5 times an x plus 2 all over an x plus 2 times an x minus a 2. Plus, here I didn't change anything about the fraction. I just factored my denominator of x plus 2 times an x minus a 2. And now that I have a common denominator, now I can go ahead and add my numerators. My x plus 2 times my x minus 2 is my denominator for both fractions. But now I can add this. You will have to distribute here so you can combine like terms. We would have a 5x plus a 10, 5x plus a 10 plus a 3. Okay? So if you want to go ahead and combine like terms, we would have 5x plus a 13 all over. You can either leave this factored out completely, or because you know it's a difference of squares, you can go ahead and write x squared minus 4, or you can just leave it the way that it is 5x plus 13 all over x plus 2 times x minus 2. Either way, they're good answers, they're perfect answers, okay? So as you can see, I'm always looking for common denominator. And if they are not common, what is the factor that I multiply by to make them be the same? The previous problem, we needed a negative 1. In this problem, we needed an x plus 2. You've got to see the denominators factored completely so you can see which factors you need, it's missing, so you can multiply it. Okay? Let's do one more example on adding or subtracting fractions. Coincidentally, I just did a bunch of addition, and here's another addition. I apologize, I didn't realize all I picked was additions. All right, let's take a look over here. We have a x squared minus 9. Notice that my 9 is negative. Here my 9 is positive. Not okay, they're not the same at all. So one of these rationals is going to have to be multiplied, okay? I like my x squared positive because I know this is a difference of squares. This is 2x squared all over, here's a difference of squares of x minus 3 and x plus 3. And then this one, it is not the same at all. We have a negative x squared and a positive 9. I know if I multiply this fraction, top and bottom, by a negative 1, I will be able to make this a positive x squared minus a 9, just like we had it here, okay? So on the numerator, we would have a multiplication as well. Now we would have a negative x minus 15, because I'm distributing this negative multiplication. Here, we would end up with a positive x squared minus a 9, which is a difference of squares, okay? So I do have both of them are the same. This one is factored out, this one is not factored, but I know they are the same. So now I can go ahead and combine. You can either write it as a difference of squares, factored out, or FOILed together. I know they're the same. I'm going to write x squared minus 9. On the numerator, we'll have 2x squared plus a negative x, which is negative x, minus 15. Okay? And then we're going to try to factor it to see if there's anything we can reduce it here. Okay? So again, I'm going to have to factor this out. X minus 3 times x plus 3. Let's see the factors of the numerator. Let's write this trinomial over here, see if we can factor it. We have 2x squared minus x minus 15. We want the factors of 2x squared, which is 2x times x. And the factors of negative 15, I think of negative 3 times positive 5, positive 3 times negative 5, 1 times 15. Somehow we need to write this and get to add up to a negative x. So let's put 2x and an x over here. How about a negative 3 here? Let's do negative 3 here and positive 5 here. Let's see if it works. This would become a positive 5x, okay? 5 times x is positive 5x. And 2 times a negative 3 would be negative 6x, okay? When I add it together, I get a negative x. It worked, okay? Coincidentally, the very first one worked, and the way I put it also worked. So this factor over here is 2x plus 5 all over, times x minus 3. There we go. So also another reason that I thought of this is because I saw a minus 3 over here. There's always a hint that I look for in the factorization of the denominator or the numerator. All right, so as you can see, we have a common factor. X minus 3 and x minus 3 can be reduced, and we end up with 2x plus 5 all over an x plus 3. So there we go, okay? So let's recap here really quick. The first fraction was not common denominators. We multiplied by a negative 1 to make it common. Then we were able to add the numerators. And then we came back to reducing fractions, okay? It took us all the way back to 4.1 where we just had to reduce rational expressions. And there we go, okay? So that is how you do adding and subtracting fractions, rational expressions, with not common, with not like denominators. We try to make them be the same, okay? And I don't have any more examples. That's it. Hopefully this can help you with your homework. Good luck.